Okay, so let's a few questions based on bias and variance. So if you look at this question number 7, what it is asking that bias and variance can be visualized using a classic example of dart game. So what is this dart game that you aim on the dart, right? So with the arrow, so so if you aim on the center, then you will have the maximum point, and we have something like that, and you uh, aim with the arrow with on this dart, right? So we can think of the true value of parameter as the bullseye on the target. So 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 let me show you options here. Basically what this is the dart, and what we are considering that this center, this with the red color, is the bullseye. And and what we are saying that we can think the true value of the parameter as the bullseye on the target. So this is your uh, actual value, so true value. So this is your true uh, true, you can say, true hypothesis, or you can say also say that this is the actual or the ideal hypothesis. So that is what according to question, and arrows values as the estimated value from each sample, and all these points uh, that our own hypothesis is estimating. These you can say, let's suppose, if this is the true hypothesis, and this is, all these are estimated hypotheses, so maybe h1, h2 hat, and s3 hat. So all these are the hypotheses. uh, uh, so based on some parameter, and this is the actual hypothesis, right? That the bullseye. So all these hypotheses that 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 this dot represents is the uh, what you have done. So from some distribution, so from some distribution you have taken maybe sample 1, and with this sample data you have trained your model with the hypothesis h1. And again, next time what you have done, again you have sampled from this distribution, that is h2, and you have trained your model, and that is uh, a similar kind of model that with h1 but with some deviation maybe, so that we are calling the h2. So all these dot represents, that blue dot represents the uh, hypothesis corresponding to uh, uh, different sample taken from the same distribution, right? Okay, now what we are saying that so let me read out one more time, that we can think of the true value uh, of the parameter. So this, let me tell you about this, more about this true hypothesis. So we don't know about this true hypothesis in actual scenario. uh, so if we know, then there would be no point of modeling to make model, right? If we do already know that. But this you can consider as ideal hypothesis. And what we try to do is make our model to reach this true hypothesis, right? So our model would be not exactly the true hypothesis, but it will be somewhere around the true hypothesis, right? So So we can think the bullseye as a target, that is the true value, and the arrow value as the estimated from each sample, right? So we have here, consider the following situation and select the correct option. So we will have to select the correct option out of these three given statement. So player 1 has low variance compared to player 4. So if you look at this player 1 and player 4, uh, so player 1, you see that all of these different hypotheses uh, uh, is somehow deviated from the actual hypothesis or true hypothesis, right? So if this is the scenario, then we call it it has high bias, high bias, right? And in case of player 4, that still we have the trained hypothesis with the different samples, and still that is again deviated from the actual hypothesis, right? So again it will be of high bias, right? And and uh, and if you see how you can see that which one has the variance or low variance, right? So we will have to come in option 1, we will have to look at this low variance. So let's look at this player 1 and player 4. So you see that, let's suppose you sampled from some you sampled the data from some distribution and you got this hypothesis, right? And again a second time you sample from the same distribution and you got this h1 hat and h2 hat, right? And if you see at the player 4, these h1 hat and h2 hat are very close to each other, right? So with respect to sampling and after sampling the data, whatever the hypothesis we are getting has we have the high variance between two hypotheses, right? Because they are far from each other, right? Not too far, but they are far. With respect to this player 4, we can say that it has the high variance, right? And it has low variance, and it has high variance, right? And with the similar analogy, we can comment on this player 3, that see, you see that 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 actual hypothesis and the estimated hypothesis function, both are the estimated hypothesis is surrounding around the actual hypothesis, so it will have the low bias. And look at those hypotheses that has been sampled from that have sampled from the same distribution, but uh, with the different sample, there is very less variation within the uh, estimated hypothesis, so it will have the we can say low variance, right? And similarly it will have the uh, low bias. So most of the hypothesis functions are around the actual hypothesis, so that is why it has low bias. And and those estimated hypotheses are the somehow they have not too close to each other, but they are a little bit far to each other, so we can say that it will have the uh, high variance, right? So I think we have marked all these. Now we can look at the options. So player 1 has low variance compared to player 4. So player 1 has high variance, and player 4 have low variance. So this option is incorrect. Now second option is player 1 has high variance compared to player 4. So player 1 have the high variance, player 1 have the high variance compared to player 4. So compared to player 4, so this statement is true. Now the second statement is bias exhibited by player 2 is more than that done by player 3. So we will have to see the bias. Okay, yes, so this is also correct. So the bias in player 2 is more than done by player 3. Okay, so player 3 have the, so this one is player 3, right? We have to compare player 2 and player 3. So player 2 is here. Let me see one more time. So bias exhibited by player 2 is more uh, than done by player 3. Yes, because you see that here all of these estimated hypotheses are on bullseye. That means all of these hypotheses, estimated hypothesis, belongs to true hypothesis, right? So it will have low bias definitely, but in compared to player 2, player 3 will have the low bias. So if we compare the bias of the player 3 and player 2, then player 3 will have the low bias. Player 2 is more than player 3, so this is correct, because player 3 will have the low, then player 2, so we can say that player 2 will have the high bias with respect to player 3. So these two options are correct, so B and C. So all right, now let's look at one more problem, that is choose the correct option from the following. When working with a small dataset, one should prefer low bias, high variance classifier over high bias, low variance classifier. Okay, if we have the dataset, then if we have a small dataset, right? That means we do not have much information, right? So uh, what we will consider, what we will focus on, that whatever model we are developing, it should have low variance, right? Because we have a small data set, and most of the things are unknown to our model. Why it is unknown to our model? Because our model has been trained by the small, given small data set, right? So while training the model, it has uh, it has it has no information. You can say that our model will not have the much diversity during the training time, because we have the small data set. So our focus would be to develop a model such a way that with the small data set, it should not get vary too much with different kind of data set. So it the main focus would be to uh, make our model with low data set, with the small data set, uh, to make the low variance, right? So one should prefer low bias, high variance. No, what we will prefer is the low variance with the small data set, right? And with the small data set, it would be fine if our uh, estimate deviates from the true value, uh, would it be fine? Yes, I think so. Okay, with the large data set, what we can say that we have the large data set, and during the modeling time, modeling time, since we have the large data set, so the diversity of the model, like the variance of model, we can cover, right? So what we will focus is to have a model that is that is that is not that should not get too much deviated from the actual uh, or the true value, right? So it should have the low uh, bias, right? So it, since we have the large amount of data set, so our focus would be to develop a model that should have uh, low bias. That means it should estimate around the true value of the hypothesis, right? So it should have the low bias. So option B and D is correct, right? Okay. Okay, I think we have solved 8 and 7, and if you look at my lecture series on machine learning, where we are solving few questions, then that this 6 number I've also solved there. 6, not 6, I think, no, not 6, but this 5 number. Okay, that is and these are from the matrix question. Okay, that was the two question from the bias and variance. That was the basic question, but it should very much clear that how you look at the bias and variance with respect to the machine learning terms, right? Okay, that is all from this video. Thank you.